In this video, we're going to be talking about choosing a model. Sometimes it's not easy to distinguish from a scatter plot which type of model will best fit our data. So you should first find several models for the data using our parent functions, and then choose the model that best fits that data by comparing the y values of the model to our actual values. You can also, after you make your scatter plot, grab your line of best fit and see which one really kind of works the best. So we're going to begin by plugging in our data into our calculator. So go ahead, and I've already got mine plugged in here. Notice that on my x's, instead of plugging in 2003, I've used a 3 to represent 2003, a 4 to represent 2004, and so you should do the same. So go ahead and push pause, and then when you're done, push play, and we'll continue. Now that that's done, we're going to go ahead and let's go ahead and graph our plot. So let's go to our window, and we'll change our window. We'll start with a minimum of 0 for our x and a maximum of 14, and we'll just count by ones, count by 1 year at a time. For our y minimums, we'll start at 0, and for our maximum, let's go up to 99, and let's count by 20s. So let's go up to 100 so that it's a little bit even. All right, so go ahead and we'll plot our data. And here, gosh, it looks like it might be linear, but just have like a little bit of bend there. So we're going to go ahead and check this out and see what exactly we come up with. So we're going to go to Stat, Calculate, and we're going to calculate our linear regression first, which is option number 4. So we'll go ahead and have that calculate. And here we'll have our slope and our y-intercept, and we can go ahead and write that down. So our linear model is f of x equals 1.55x plus 68.8. And if we were to plug that into our y equals, we would see 68.8. You graph that, it's pretty close. Kind of sits above and below some of them, so that's pretty close. Let's go ahead and let's calculate our quadratic model, because it did have a little bit of a bend to it. So we'll calculate our quadratic model, which is option number 5. And when we do that, we'll find that here's our a, b, and c values. So we'll go ahead and write our equation. And so we have our quadratic model is g of x equals 0.107x squared minus 0.16x plus 74.6. So if we plug that in, let's go to our y equals, we'll put this on our next one. So let's see, 0.107x squared minus 0.16x plus 74.6. Oops, so that's kind of in a wrong spot. So let's go back up here and take care of that really quickly. Just add that in. So plus 74.6. Okay, so we're going to kind of graph that one. And that looks like that might fit too. So we might want to zoom in here. So I'm going to change my window on my y value. And instead of going from 0, I'm going to go from 50. It kind of looks like our red model, or our quadratic model rather, is what we want to choose. So basically we're determining which model fits the data better. So we're comparing the y values given with each model to the actual y values. So we're comparing our line to our scatter plot. So in this case, the better fitting model really is that quadratic model, that curved model. And so we'll go ahead and say that our quadratic model is our best fitting data model, and that would be g of x equals 0.107x squared minus 0.16x plus 74.6.